right, our second lesson with polynomials in 930 is adding and subtracting. So we're going to start doing some operations with these polynomials that we learned what they were all about in the last lesson. And we're just going to focus on adding and subtracting right now. And I would guarantee you're going to find this to be something that you've been doing a long time. You just didn't know that it was called adding and subtracting with polynomials. All right, so warm up here. Which one of these do you think is true? 2x squared plus 3x squared equals 5x to the fourth is A, and 2x squared plus 3x squared equals 5x squared is B. Pause your video and see what you think. All right, so if you remember your exponent properties, right, I don't ever add the exponents unless I'm multiplying like bases. And in this case, I am adding them, right? So I do not change my exponent. Letter B was the correct one. It's the variables stay exactly the same when you're adding. If I was multiplying these, that's when they would change exponents. So in this case, I kind of just think like x squareds are my thing. Like there could be 2 bananas plus 3 bananas would give me 5 bananas, right? The bananas don't change. That's just telling you what thing you're combining together. So when I have 2x squareds plus 3x squareds, I end up with 5x squareds. So the variables and exponents do not change when adding or subtracting. When you're multiplying or dividing, that's when we learned all those exponent properties right in the last unit. So just kind of remembering, or 2 units ago, I guess. All right, that's going to be really important today, so it's good to remember that right away. So just a tiny little bit of vocabulary today. I know we hit the vocabulary really hard yesterday with all of our polynomials. So just reviewing, we kind of briefly touched on it yesterday. But if I'm talking about a term, that is considered one of the monomial parts of a polynomial, right? A monomial part of a polynomial. And if you remember from yesterday, remember like a monomial, we're talking about, right, a number, a variable, or a product of numbers and or variables, right? Things that are connected by multiplication, right? If I have a plus or a minus, that's the separator between terms. Okay. Maybe we've been, you got the idea. All right. So again, a term, if I give you an example here, if I have a polynomial that is, say, 5x to the fourth minus 3x squared plus 5x minus 8. All of these pluses or minuses are separators of terms, right? So I'd have 1, 2, 3, 4 terms in this polynomial. Okay. Now when we talk about like terms are terms that have the same variables with the same exponents, right? So you have to be careful, right, that they have the same exponents on those variables. All right, so same variables with the same exponents. So I'm just going to give you some examples here of like terms. So for example, I could have 14m and negative 1m, right? They both have just an m. Those would be like terms. I could have something a little bit more complicated. I could say 32n to the fifth and 28n to the fifth. Again, they are both n's, but they are both n to the fifths, right? So that would count. I could have 6x squared y and negative 8yx squared. Notice I have a x squared in both, and I have a plain y in both. I have the exact same variables with the exact same exponents. Even though they're not in the same order, they're still like terms, so be ready for that. Here would be an example of not like terms, okay? Not like terms would be like 5x squared and 6x to the 4th. Those are not like terms. They both have an x, yes, but one is an x squared and one is an x to the 4th. Okay, you kind of see the difference there. So they have to have the same variables with the same exponents to be like terms. All right, so let's say that I have these polynomials, right? And I would like you to combine the like terms. We want to simplify by combining like terms. And we always want to make sure that any answer that we give is completely simplified. There are no like terms that are left. We want to combine them up. So if I look at number 1 here, if I'm looking for my like terms, I would see, okay, there's a 4y squared and an 11y squared. I'm going to combine those. And remember from our warm-up, the y squared doesn't change. 4 bananas plus 11 bananas is 15 bananas, so 15y squared. This negative 6y is a different kind of term. It doesn't have the same exponent, so it cannot get combined. It's just going to stay as negative 6y. Remember that we need to write our answers in standard form. I happen to do it as we went here, but something that we just want to keep in mind, to write answers in standard form. So again, standard form means you'll take the highest degree first and then all the way down, decrease in order from highest degree down to lowest. So that's why I had to put the y squareds first and then the y after that. Okay, let's look at number 2 here. Definitely trickier, but remember, like terms have the exact same exponents and the same variables. So if I look through this, I have an n to the 4th m. I have an n squared m to the 3rd. That's definitely different, right? Those are not the same variables. Well, they're the same variables, excuse me, but they are not the same exponents on those variables, so they are different. But the next one, I have another n to the 4th m, so that is a like term with my first one. So I have negative 15n to the 4th m and negative 4n to the 4th m that I am going to combine. Remember, variables don't change. I'm just adding those numbers in front. Negative 15 plus negative 4 gives me negative 19, n to the 4th m. And then my plus 7n squared m to the 3rd cannot be combined with those. Now, if I'm going to check for standard form, remember this is I have to add the exponents, so there is an invisible 1 here. So 4 plus 1, my degree here is 5. Oh, but 2 plus 3, my degree here is 5. So in this case, it really doesn't matter which one you put first. So this one is definitely standard form the way it is. You could have switched the order, still would have been in standard form. So if they have the same degree, it doesn't matter which one you put first. Okay, same idea here. Let's look at number 3 now. Negative 12x plus 7 minus 9x to the 4th plus 24x squared. I have an x in the first one, no variable on the second term, x to the 4th on the third term, x squared on the last term. There are no like terms. That's okay. That just means that all I need to do is put it into standard form. So the highest degree was my x to the 4th. So negative 9x to the 4th will come first. Then I have my x squared, looks like that's next, plus 24x squared, minus 12x, and then finally plus 7. So If there are no like terms, that's okay. Just make sure that you write your answer in standard form. And that was a really good practice of writing in standard form because we hadn't really hit that too much so far in this lesson. Okay, so that's when you have a single polynomial and we just want to simplify it using our like terms idea. Now in number 4, I'm actually adding two different polynomials together, right? Notice this first polynomial has 1, 2, 3 terms. Remember what a 3-term polynomial is called? It's called a trinomial, right? And then in my second one, I have 1, 2, 3 terms. So that's also a trinomial. So I'm going to do with it a trinomial plus a trinomial, right? That's the idea here, is sometimes you're going to have these expressions that you want to add together, okay? So usually we'll put parentheses around a single polynomial if you're dealing with it in a bigger sense when you want to add, subtract, things like that, okay? However, if I really think about this mathematically, in this case, is there any number outside of the parentheses? Am I distributing anything? Not necessarily, other than that invisible 1. However, I know, like it is ingrained in me, that I cannot combine things that are locked into parentheses. So what I need to do is distribute that invisible 1, or you can think of it as just rewriting it without the parentheses before you start adding or subtracting. But I'm just going to do it right now. So 4x squared minus 6x plus 7. And I want to add that to my second trinomial, again, invisible 1 listed out here, distributing that, 2x squared minus 9x plus 1. Well, now it kind of just looks like these last problems. All I need to do is combine my like terms. And I'm going to kind of make sure I write in standard form as I go, so I'm going to look for my like terms with the biggest exponents first. So this will be 6x squared. I'll have negative 6x plus negative 9x gives me negative 15x. And then I can add my constants here. Plus 7 plus 1 gives me plus 8. And I wrote it in standard form as we went. So when you add your polynomials together, no matter how many terms they have, those parentheses are there just to show you the original polynomials. You just need to rewrite without those parentheses before you start combining. And I'll show you why in a little bit, but you have to do that. I am a stickler about that. You cannot ever combine things that are locked into parentheses. So you got to get rid of the parentheses before you start adding your like terms. All right, so look at number 5 here. Again, more going on. I see 1, 2, 3 terms, trinomial. I see 1, 2, 3 terms in the second one, that's trinomial, but this time I'm subtracting them. So I'm subtracting 2 trinomials this time. Okay, so in this case, it is really important that you think of it as distributing your negative 1, especially when it comes to that second set of parentheses, right? I'm subtracting that. So I'm going to rewrite this first one without my parentheses. And I have actually a different method to show you on this one. It's going to be doing the same kind of thing. However, I'm going to sneak my invisible 1 in there, but remember I'm distributing a negative 1 this time. Negative 1 times negative 9y to the third gives me positive 9y to the third. Now instead of just, I could write it right here, right? That would be fine. But I know that I'm going to be combining my like terms in the end. So instead of writing it there, I'm going to write it under the other one that's the same term. It'll help me later on combine the correct things and not miss anything. All right, and so then I'm going to distribute my negative 1 to my next term. Negative 1 times 12y squared is negative 12y squared. And negative 1 times negative 7 is positive 7. And now I'm going to add these two up, right? Because I need to combine my like terms. So 8y to the third plus 9y to the third is 17y to the third. Negative 6y squared minus 12y squared, negative 18y squared. Negative 3 plus 7 gives me positive 4. And since I was making sure to write them in my degree order and then lining up my like terms, I've already written it in standard form as well. Now, you could absolutely take this guy and put it up. Whoops, not that. Not the y as well. Okay, but you get the idea, right? I could take this. It's not going to let me do that. I apologize. And move it over here and write it the same way that we saw in the last ones and just look for your like terms. Perfectly acceptable. Absolutely, you can do that. This is just another method. If you're finding that you're having a hard time keeping track of like terms, you miss something, I keep making mistakes, I think this is a fabulous method. In fact, I do this a lot, even when I'm just doing my own problems. So just something to think about. Okay, I'll probably show it this way, like I said, because that's kind of my habit and it might help you. But by all means, feel free. You can just write it all out. Just remember, you cannot combine anything that's locked into parentheses. So make sure you distribute those ones or negative ones before you start combining. All right, let's take a look at number 6 here. Okay, so in this first set of parentheses, so here I have 1, 2 terms. So this would be a binomial, right? And then I'm going to subtract another binomial and then add a third binomial, right? These are all 2 terms. So before I do anything else, I will need to distribute so I get rid of those parentheses. First set of parentheses stays exactly the same. Negative 4ab plus 6cb squared. Now I notice, cb squared, that has a bigger degree, but maybe I'm not going to worry about that so much right away. Let's just keep it in the same order so we don't get ourselves too confused. Okay, but if you wanted to write it in degree order right away, it wouldn't be a bad idea. All right, now here I'm distributing my negative 1, right? So be careful. So now I have negative 8ab, and I have positive 3cb squared, right? Negative 1 times negative 3 gives me positive 3cb squared. All right, my third parentheses, I'm distributing a positive 1, so this one's not going to change. So I'll have 5ab, but this last one is negative 6c squared b. That's not the same thing as cb squared. So I'm going to write it over here to make sure that I don't combine it with something that it's not a like term. Do you see how writing it underneath this method might actually help save you some little mistakes in the long run? Because when you see it in this huge list, it's really easy to think that those are the same and just add those numbers up, right? But when you're writing it down and you start to write c squared under the c, wait a second, those aren't the same. And it'll help you catch that. Okay, so now I'm going to add up all my like terms. So negative 4ab minus 8ab, that's negative 12ab, plus 5ab, that would be negative 7ab. Negative 12 plus 5 would be negative 7. Okay. Then I'm going to combine my cb squareds. 6cb squared plus 3cb squared is 9cb squared. And I don't have a like term with this other guy, so it's going to stay the same, 6c squared b. Now, remember, write our answer in standard form. This one is not in standard form right now because this first one has a degree of 1, 2. Second one has a degree of 3. Third one also has a degree of 3. So it doesn't matter which one of those 2 you write first. I'm going to write the 9cb squared first just because it came first. Minus 6c squared b minus 7ab as my final answer. All right, hopefully that's starting to make sense to you. Now you could see this idea of adding our polynomials in a different way, right? Perimeter. Find the perimeter of the figure. Remember, perimeter means add up all the sides. So I have this trinomial to start with. I have this binomial down at the bottom, and I have a binomial over here on the left. I need to add those together. So we could write it all out, right? 4x squared minus 3x plus 9 plus 2x minus 6 plus x squared plus 5. Or, and then you have to get rid of your parentheses and all that. Or we could just write it above and below like we've been practicing on all the other ones, right? So I have 4x squared minus 3x plus 9. Then when I write my 2x minus 6, I'm going to line up the correct parts. So 2x is going to go here, minus 6 under the 9. And then when I add my x squared, it's going to go under the other x squared, and the plus 5 is going to go over under the constants, right? My plain numbers. And then I'm going to add them all up. So I have 4x squared plus 1x squared gives me 5x squared, right? I have negative 3x plus 2x gives me negative 1x. Now you could write negative 1x, or you can just write negative x. That works too. And then I have 9 minus 6 is 3. 3 plus 5 is 8. So the perimeter equals 5x squared minus x plus 8. And just to double check, x squared, x, no variable. I did write it in standard form as we went. So perimeter is a pretty common way that you could see this adding polynomials idea. Here's the last way you might see it, just a little bit different. So it says, what must be added to the polynomial negative 3z squared plus 16z minus 8 to get the result of negative 6z squared plus 10z plus 5? What must be added to the first one to get the result of the second one? What must be added to this? So I'm taking this negative 3z squared plus 16z minus 8. I'm going to add something, right? I'm going to get the result of negative 6z squared plus 10z plus 5. Well, if I want to figure out what is it that I'm going to add to the red one to get the result of the orange one, really what I'm doing is subtracting this one, right, from both sides. Oops. So that it cancels over here and I'm left with my green blank. So I have this green one minus what was my red one, right? Maybe I even want to turn this guy red so you can see that I'm really subtracting my red polynomial. Okay. So this is a different way of writing a subtraction problem. What must be added to this to get a result? Well, you want to subtract that so that you find out what you had to add to it, right? So it's kind of confusing, but I wanted to show you this way. So really, if I rewrite this problem is really saying the result, oops, helps if I write with a pen. The result, negative 6z squared plus 10z, the bigger one, plus 5. Minus negative 3z squared plus 16z minus 8, okay? And now it looks exactly like all those problems we've been doing before. So my first one, I'll keep exactly the same, negative 6z squared plus 10z plus 5. The second one, I want to make sure that I distribute that negative 1. And this is why it's extremely important that you show your work on this, because this becomes positive 3z squared, negative 16z, and then positive 8. And if you didn't show your work properly, your answer probably would not make sense, so be careful. So negative 6z squared plus 3z squared is negative 3z squared. 10z minus 16z, negative 6z, 5 plus 8, 13. Okay, now, please, again, make sure that you are showing your work. So you have to show this step where you distribute that negative so that you know that you have the correct positives and negatives on anything, or you are most likely going to get the wrong answer. So that was a big one. I wanted to show you a different way of seeing a subtraction problem and make sure you're showing your work. So we saw a different way of seeing an addition problem with perimeter, and this is a different way of wording a subtraction problem. All right, just, wrapping it up here. Add or subtract those like terms when you're simplifying polynomials. Remember, if they show you those polynomials in parentheses, you have to get rid of the parentheses before you can combine, and watch out those negative ones. Make sure you distribute that, okay? And then if you forget perimeter, that's when you add up all the outsides.